Hi everyone. In today's session, I'm going to be discussing about Musa Al Khwarizmi, Muhammad bin Musa Al Khwarizmi. He was the greatest Persian mathematician. He was a Muslim mathematician, astronomer, philosopher, and inventor of algebra. Algebra or al-Nisab or al-Mukhtasar. I'm going to talk about that one in later um, kind of presentation pages. That At this time, let's just talk about Al-Khwarizm, who he was. He was born in the 7th century, between 780, and then he died in 8th century, um, around 850. And then he was living in Baghdad, which was at one point the great Persia Empire, which was part of Iraq and Iran, Afghanistan, Tajikistan, all together was called Persia or the Persia Empire. And then at that time, he actually lived in the House of Wisdom, which is now it's called Tajikistan, but at that time was the Baghdad, which was the House of Wisdom, all the knowledge of wisdom, the wisdom of knowledge was the place that all the scholars of the 7th century was just doing everything, including economy and then business and everything that was there was the House of Wisdom was there. So in this video, I'm going to be discussing about the life of Al-Khwarizm. And algorithm, which we nowadays know is derived from the name of Al-Khwarizm. As you can see here, I wrote the modern day algorithm is derived from his name, Al-Khwarizm. We all know algorithm very well, which is the building block of computer science and coding. Every computer program needs an algorithm. Every time you write a set of steps to carry on some computation or calculation, whether that's a finite set of steps, just does some function calls, some methods, some procedures, whatever you do on the computation parts, it is the algorithm behind it that makes the software or operating system database, all the modern day things that you see, whether it's electric vehicles or you can see it on a remote controller, there's some coding behind it. So you can see on the entire computers with it algorithm. So Al-Khwarizm important contribution was Algebra. Algebra, a word derived from the title of a mathematical text he published in the 8th century, around 830. It was called Al-Kitab. Al-Kitab, Kitab means book. Al-Kitab or Al-Mukhtasar. Al-Mukhtasar means the brief or summary or kind of like not too detailed. So a Mukhtasar or Mukhtasar. Al-Mukhtasar was like kind of for sure that or summary of what this book was there. And then also Al-Mukhtasar fi Hisab. Hisab is the calculation. Hisab also is to sum up some numbers between like you calculate addition, subtraction, division, multiplication. The book that we studied at high school back in Kabul, Afghanistan, was also called Hisab. And then after that, later on, after 7th or 8th grade, we studied from first grade to 7th or 8th grade, the book, one subject called Hisab. And then later on, that book changed to mathematics or Riyaziyat. Riyaziyat was kind of like mathematics. And then at the same time, there was Drake, which is Musallasat and other books. So we had to study it in 9th grade and on with trigonometry and which is Musallasat and Handasa and all of that one we had to study. And then Algebra, which was another title for the same book. Algebra, Jabr means the a force, basically. Algebra is like a force or pressure. And then while muqabala means to compete, competition, or in other words, in muqabala is the Farsi word or Arabic word or Urdu. Muqabala is also to compete with somebody. There's another one is whenever you or competing, you're doing muqabala or amsari or hambarabari. All of those words are similar to muqabala. So this Persian mathematician, he did not have a war or kind of like a weapon of mass destruction that George Bush lied to the people and then went to Iraq and all of that. There was no such thing in Baghdad at the time. Everything was knowledge and the house of knowledge, and everybody was trying to do an internal muqabala or like jabr or force to carry on some kind of invent or not carry on, to invent something like he invented algebra that served the humanity for centuries and for many centuries to come. And then as a result of algebra, we had Boolean algebra. And then from Boolean algebra, we decided to have other books, which was mathematics and trigonometry and other ones. So Al Khwarizmi was a great mathematician. And then here I just talk about these ones, but as you can see on this one, Corona Brizia, a very nice picture that he or she drew that one, and this person drew it, and then I just give the credit for the nice picture. At the same time, you can see the triangle options of Pythagorean theorem. You can see radius as the square root of radius is the square of is equal to the square of the base in height, which is r square is equal a square plus b square, or a square is equal b square plus c square is equal a square plus b square. So whatever is the radius, the square of that one is going to give you the square of those two. So at this time, you can see that he was thinking of trick geometric shapes and also the numbers. So when he invented algebra, what you are going to see, he came out with these numbers. So he put the Greek and Indian numbers together, because the Greek and then the Egyptian and all the Indian numbers, a lot of these numbers were really kind of hard, especially the Egyptian. They had symbols and then do symbols. If you had to write 9, you had to write 9 like with 9 symbols, or to represent the number 9. And when you do the 99, and it's like 99 symbols, that is kind of really hard to multiply and add it. And then also the Greek numbers, if you write a 5, you write a V, and then when you write a 4, you write a V with an I next to it on the left side. And if you want to write a 6, you write to the right side of it. So all those numbers, there was very hard to complicate bigger numbers. One like 20,500, and if you have to add them up, you have to write that many symbols or millions of numbers. It was impossible for them. And so the Egyptians were using some kind of a stone to carry on, and even that one was impossible. So what Al Khwarizmi did, he came up with these decimal places number of base 10, which is 0 through 9. So the 0 has no angle, and then the 1 has one angle. As you can see here, which I'm going to demonstrate here. So let's go with this, and then you can see here 1 has one angle here, and 2 has 2 angles. Let me move this one out of the way, and I'm going to show you the 2. The 2 is I'm going to highlight the color first. So the 2 you can see here is 2 angles. And similarly, the 3 has 3 angles. So based on this, he just came out with these kind of symbol that represent the number system from 0 through 9. And 0 has no angle, right? So you can see 0 has 0 angle. It's like a circle. And then 4, you can see it is 1 angle here, 1 angle here, is a triangle kind of things. Similarly, 5 has 5 angles. You can get the idea, right? So if you count those ones, there's 3, and then we just move this one a little bit more here. So that's 1, 2, 3, 4, 5. And then similarly with 6, you can see here. So you got the idea. I'm going to just do the 8. And then look at the 8, for example. Let's just use a different color. It's not giving me the option to choose a different color, but it's okay. With the same color is fine. So 8 is 1 here and 1 here. If you put 2 triangles on top of each other, then you can see there's 3 here, 3 on each triangle, and then the combination of the 2 makes another angle here and another angle here. So that's kind of like 8, right? But then you could write 8 with 2 squares on top of each other. That square would be closed square like this, and like this. This is a square. So if you close this one, this would be an 8. And then each one of these angles, like here is 1, there's 2, there's 3, this is 4. But because this is 6, it has only opening here. But 8 would be closing, so it would be an angle here and an angle here. You could write it with 2 square on top of each other, or this. For the 9, as you can see, the angle, he has 1 here, 1 here, and then 1 here. That's 4, 5, and 6. And then 7, 8. And then the next one is right here. The one that is the end of the number 9 going down, that's another angle here. So if you just kind of zoom in on this one, and you can see the pictures here, that is between them. It's an angle here, an angle here, an angle, and then 5 of them here, and then 4 on the top. That's 9. Similarly for 8 of them. So those are very nice to do it. And then you might just say, what does this angle means? He was thinking of when he went to Baghdad, he was talking with his teacher. His teacher first told him why you feel a little bit more stressed and kind of worried, that you feel kind of stressed, and then what is going on in your mind. And he mentioned that to his teacher after praying namaz, and then in the masjid, and then he was just saying that, teacher, all I think of look at the palm trees in terms of shapes and angles, and what is the distance, what is the volume, what are these numbers. That's what my mind is going, what's going on in my mind. And then the teacher noticed that he would be a great mathematician, and he would be kind of like proceed with his life if he goes to Baghdad, the house of knowledge. He's going to just do something big for the humanity. And that's what his teacher offered him, to go and leave your father to me. I'll take care of them, and then just go. You don't need to be in the farm, and just you need to invent. And then he went to Baghdad with all those other wise men and all the people that they were just inventors and researching knowledge and seeking knowledge. Even in the Holy Quran, it says, seek knowledge from the day that you're living until the day you pass away. Doesn't matter how long you live, you have to serve the humanity with your knowledge, and knowledge is power. Sharing is caring. By sharing, you makes everyone powerful. So he shared this knowledge, and today we are just seeing it after the 7th and 8th century. Today we're seeing so many things available for us as a result of his invention. So And this one, I saw this video, this picture, I agreed with everything, but he is every century mathematician, because he started with algebra that caused everything to grow as a result of algebra. And then we're going to talk about some of the nice things that he did for algebra and mathematics. So let me go to the next video, next page. So the PowerPoint presentation that I have here, you can see basically Al Khwarizmi was thinking of all the geometric shapes and numbers and everything when he invented algebra. But as you can see here, people are writing all kind of mathematic formulas, summation, integrals, and with a triangle, they put it, but then they are putting some formulas that it started with numbers and then with triangles and geometry shapes, but then from algebra or math I'm sorry, from algebra, we went to mathematics. From trigonometry, we went to pre-calculus, and then from trigonometry, pre-calculus, we went to calculus, and calculus, integral, and then derivative, and all that is just coming. Parabolas and everything is coming as a result of, as I mentioned. So here I'm having two nice picture of him, just like maybe statues, like stone pictures in Baghdad, or images. I have it as image, but it is actually a statue. And then you can see here, basically, Al-Khwarizm's important contribution was algebra. Algebra, or al-Hisab, or al-Mukhtasar, or fi hisab, you can call it, or al-Muqabala, al-Jabr. Jabr means like force, and then a word derived from a title of his mathematical textbook published, Al-Kitab al-Mukhtasar. Al-Mukhtasar means brief, something like summarized. Fi hisab, we also had a book that I mentioned it in Habibi High School when I was studying until 7 or 8. I studied in elementary and middle school to Sayyid Jamaluddin Afghan middle school, which was first elementary and then become middle school. And then after 8th grade, we went to Ghazi. And then after 3 months from Ghazi high school, I kind of moved on to Habibi High School. And then just so because of soccer, a lot of good friends there. And then played for Habibi High School for so long, for many years. And then we had Habibi on club. We played it. So, and this some of these things or books that when we talk about the South, it is bringing great memories, especially this picture. This picture, black and white, I can think of Kabul, Afghanistan, when we were studying Hisab, the book Al-Hisab, Fi Hisab, which we call it Hisab. And then that book was all in black, written on white paper. And then I believe somehow I could recall the picture, something like this. I was too young to remember basically the name Al-Khwarizmi, everything, but this black and white pictures rings a bell, saying that maybe there was on every Hisab book mention about Al-Khwarizmi, and this picture could have been there. That's why it brings a memory there. So in this picture, you can see Al-Khwarizmi wrote the name of his book, Kitab Al-Khwarizmi. So right here, if I just zoom in on this part here, let me just zoom in on this part, you can see Kitab Al-Khwarizmi. And then Kitab Al-Khwarizmi is basically in Arabic or Farsi, you could say it's written. This is Qaf, Tay, Aleph, Bay, Kitab. Kitab means book. And Al-Khwarizmi, Aleph, Lam, Khay, Waw, Aleph, Ray, Zay, Mim, Ya, Al-Khwarizmi. that is also written in there. There's a lot of other names here that you can see, Hussein bin Muhammad and bin Ali, and all that information that are written here. You can see that Ibrahim is there, and then and here Hasbunallah wa ni'mal wakil. So I'm going to show you that one also on this other one, because let me just go to this page, and then we go to the next one. So right here, let me zoom in on this part. Right here, you can see when we zoom in, it's written Hasbunallah wa ni'mal wakil. Hasbunallah wa ni'mal wakil is this word, and nowadays everybody, all Muslims, they say this thing because it's in the Holy Quran. It says that Hasbunallah wa ni'mal wakil means, in English we could say Hasbunallah wa ni'mal wakil, but it says Allah is sufficient for us, and He is the best disposer of all affairs for us. So basically, it's saying that for everything I seek Allah, He is sufficient for me to protect me and help me. That's what Hasbunallah wa ni'mal wakil. So when he was talking about internal kind of jihad, to just say, I'm going to write Algebra, or I'm going to study so I could serve humanity, that's an internal cleaning. Jihad does not mean fight. The word, you can say it in Arabic, jihad, but sometimes if you do something for good cause to help humanity, that's also internal cleaning. And then just knowing it. Don't worry about those bad words that people they use, and then don't do those ones, because nobody that wants to serve humanity, nobody that was like these kind of respected scholars that they did so much for the humanity till today, and billions of people have jobs, and billions of people are enjoying computer science, technology, Google, internet, and electric vehicles, airplanes. All of that one would have been impossible without Algebra. And Algebra was the one that actually put us to mathematics. Mathematics put us to physics, and physics and mathematics and algebra made things like NASA and all of these technology that nowadays we have astronomy and everything is as a result of his invention of mathematics or algebra first. So Muhammad bin Musa, his name was Muhammad bin Musa Al Khwarizmi. Bin means son of, or sometimes you could say Ibn, or his name was Ibn. Muhammad ibn Musa Al Khwarizmi, because his name was from the city that he left. Al Khwarizmi was a tribe in that Baghdad at the time. So Al Khwarizmi, it's not Khwarizmi, it's Al Khwarizm. Khay sound is in Arabic or Farsi, Khwarizm, Al Khwarizm. Al Khwarizmi was a Muslim mathematician. He was an astronomer. You can see that he was talking about astronomy and Earth and everything at that time, in order to think of those geometric shapes, also the distance between sun and moon and everything, and then the moon and Earth. All of that one had to be doing with calculation, right? So, and astronomy, whose major works introduced the Indo-Arabic numerals, and then the concept of algebra into European mathematics. European mathematics basically is that everything later on the Europeans in England and other kind of like great mathematician that there were, whether George Boole for Boolean algebra came out, or Newton, or any other one, Einstein, or every one of them, that they invented these great things for humanity. At some point, they served the humanity, was based on the root was algebra. And the root of algebra was basically Al Khwarizm. So Al Khwarizm invented algebra, and then algebra helped trade in geometry and everything. at the same time mathematics, and mathematics was born, and then everybody came out with more knowledge everywhere. So you can see here, and then this one is also Khwarizmi, the way it's written, Al Khwarizmi. He lived between 783 to 850, and he died at 850, and then his great contribution was on algebra to begin with. So without Al-Khwarizm, we would have never had algebra. Without algebra, we would have never had Boolean algebra. Boolean algebra, the greatest mathematician of England was George Boole. George Boole was a great mathematician of the 19th century. Imagine that Al-Khwarizm came out with algebra in the 7th and 8th century, and George Boole came out with Boolean algebra, which is Boolean logic. Boolean algebra that invented all the zeros and ones for the computer, for the gates and circuits. So every gate that was an OR gate, AND gate, OR gate, NAND gate, all of that, the XOR gate, all of those gates made the computer circuitry, and then the computer was kind of like invented as a result. And then on the computer, you had to write an operating system, and then you build operating system like Windows and Linux and Unix and all these other ones. And then the major computer science was taught at the school that teaches computer programming and computer software engineering and database, operating system, networking, everything all together. All of that one would have been impossible without a computer. So there would be no computer science if we didn't have computer. And if we didn't have a circuit in gates, we wouldn't have computers. And if we didn't have Boolean algebra, we wouldn't have gates and circuits. And if we didn't have algebra, you could not have any of these Boolean algebra or other. Even though George Boole might have come up with something, but his knowledge was based on algebra that already existed. So by Al-Khwarizm. In mathematics, once you have algebra and other ones, then later on, these numbers, you could do sets and other ones, and then trigonometry with algebra and all of that. But with mathematics, you add on to more powerful stuff like statistics and calculus and all linear algebra and this and that, all of that. So algorithm, which was the set of steps that you carry on a program, you write a program to calculate some computation. This is set of steps could be not infinite. Otherwise, it would be an infinite loop. It would be one or more kind of steps to carry on some computation. So it's a finite set of steps. And without algorithm, you could not write software. So if there was no algorithm, there was no way to write a software. Without the software, you would have no Google, no YouTube, no Bing. And obviously, without a computer or software and hardware and the things that are there, none of this would be possible. Google would not have their storage that they're doing. They wouldn't have all these robots and all the Google bots or Docs, the search engine. All of the things that you are using, YouTube videos and graphics and images that you're watching and everything would be impossible without a computer, without software engineering. So there would be no Google, no YouTube, no Bing, no Yahoo, no Microsoft, no IBM. IBM is a hardware and software company. No Amazon. Amazon Web Services would be useless. There would be no Amazon, nothing. And no cloud computing, no Cisco. Cisco is the building block of internet for everything that we do on the internet. And then if there was no internet, obviously, or no hardware, no software, there would be no Cisco, no IT, information technology, no AI stuff, no chat GPT, no nothing. AI, artificial intelligence, no machine learning, ML, and no robotics. There would be no robotics because of without mathematics and without calculus and without physics and without computer, without all these hardware and software, there would be no robotics to work. There would be no operating system to run these robots or computer hardware or software. No data science, and there's no data analysts, there's no programmers, no software developers, no database administrator or no database software, no cyber security stuff, no electric vehicles, and no networking. And when you don't have network, you don't have internet. So no internet without computers, and none of those ones would be possible. So all of these ones, imagine how many billions of people would be out of jobs with all these industries that we can think of, whether it's airline or business or web stuff, internet or software engineering or medicine or anything, the science and earth research, anything that you can name of, it has the need for a computer. When we were talking about 2000, we're talking of, it's going to be end of life because there's a time kind of constraint that is going to fail. None of that happened because the time and everything could be always synchronized. But imagine if you don't have a computer, if you don't have software engineering, you don't have computer that is running on a hardware. There's no circuitry, no gates and other ones to do that computation. So how you could have it? So, and this would be just like the whole job in the market would be down. We're back into forms and back to 7th century or 6th century. God bless everybody. It's life is not over, because whenever there's no such thing, God created humans to just invent and then serve the humanity. And there are a lot of people they do that. And last but not least, on no YouTube, I wouldn't be able to just make this video for you to just serve you. And I wouldn't be able to just study computer science. I wouldn't even be able to work on computers. I wouldn't know Algebra. I wouldn't know how to add up numbers with symbols and all that kind of combinations. Imagine all that is made so easy because of Algebra. God bless Al Khwarizm. And then I hope you enjoyed this video and then learn it. And so I'm going to discard the changes and then save this one. And here you can see George Ball, Boolean algebra inventor. So I'm going to have some other videos that discuss about George Ball also. But that Hasbunallah wa ni'mal wakil, I searched it on Google, and then I saw a lot of other nice video or pictures that was there, and then I took this one and I pasted there. You can see here that is basically coming from Google search. So all that Google search would have not been possible for searching for Khwarizmi. And if I just go here on Google, just to show you today, and if we say Al Khwarizmi biography, for example, or something, you can see that there's thousands of Wikipedia and other ones about this. And then I want you to just watch this video also. This video that I watched is really nice. And then that one, Muhammad bin Musa Al Khwarizmi. This is what this one, his name is Muhammad bin Musa Al Khwarizmi. You can see that one. But this video, I could play a little bit of it so you know what I'm talking about. That way you could watch this video. And this one is about the life of Al Khwarizmi. It's a very nice documentary. You should see this one and enjoy it. And then
1, 0, ignition sequence starts.
Okay, so I'm going to just move it a little bit and then see the part that I want you to see is when he talks with his teacher. Right here, you can see.
He is Muhammad, who was observant, passionate about research, science, and knowledge. He is Muhammad ibn Musa Al Khwarizmi. Al Khwarizmi lived his youth in Cordoba, where he used to spend his days, either among scholars or in the family farms, helping his family in cultivating and caring for them.
And then I'm going to just this part is really important, where he sees everything in geometric shapes. Let's see if I.
House. To an extent that my head is filled with intersected lines and various geometric shapes, imaginations and images to accompany me during my wake and follow me in my dreams while sleeping.
My son, if I'm guessing correct, you will excel in mathematics. So go to Baghdad to seek knowledge, and do not waste your time on farming fields, lest your energy go to waste.
But I help my father in farming and I can't.
Go to the House of Wisdom in Baghdad. I am sure you will find what you seek. And leave farming to farmers. As for your father, leave him to me.
Thank you, my dear teacher.
May God bless you.
Peace be upon you.
Peace be upon you too.
Established by Caliph Harun al-Rashid.
So he went to Baghdad and then the House of Wisdom and seek knowledge, and today we have Algebra. And because of Algebra, it's the root of mathematics and everything that started, and then now we have so much technologies that God bless Al Khwarizmi. This is a movie that was kind of made up for documentary purpose. Obviously, the movie is very nice, kind of video with colors and everything with documentary. You're gonna enjoy it, and I hope you also seek knowledge and serve the humanity. Take care. God bless you all. Have a good one. Bye bye. And last but not least, if you have not subscribed to our channel, MyWebUniversity is my YouTube channel that I have these videos for you. You're welcome to just go, and then thousands of videos are there for teaching you these kind of computer science related programming on operating system. And if you want to use my website, I have the online book also available, 14 chapters. Everything is online and you can learn it. There's a lot of technical documentation, 32,000 PDF files available on this website for you. And you don't have to buy books, and everything is, you don't have to have, everything is online on the browser. And then you could just have an internet access and a browser and the desire to learn. I teach you everything, and if I don't give you an answer, there's already documentations that were written by millions of people in PDF formats that since 1969, these books and technical documentation have been written in many operating system and many programming languages. So I'm presenting you all of them in one interface, one page. And then if you just go, for example, if you look at Red Hat Enterprise Linux 9, there's about 12,000 PDF files, section by section. Each one of them you click, like sine hyperbola 3.pdf, you can see that we were talking about, look, what a kind of like close look. We were talking about math and trigonometry and algebra and all of that. And the first thing that caught my eyes was sine hyperbolic dot 3. 3 means the section 3 of manual pages. So you can see that it's math.h is included, and sine hyperbolic is returning a double. This is all in C programming language, so that you can see that the whole thing is there. And these numbers and not a number, all of these functions, all of this would have been impossible without math and algebra. So you're welcome to watch these ones and then enjoy it. At the same time, I have YouTube in Farsi. So if you're from Afghanistan or Iran or Tajikistan and you speak in Farsi language, I'll make this video also for you in Farsi, so you could enjoy it also in Farsi. I have some of these videos for you that you could learn also. And then please subscribe if you haven't done so. Here I'm seeing a lot of people are subscribing and a lot of nice comments and questions that I'm answering some of them. If I didn't get to your question yet, I will, just because I'm also tied with a lot of things that I'm doing in my full-time job, as well as, you know, on holidays and vacation. So just stay tuned and you will see some answers if I have not answered it yet. And then with that in mind, I'm going to finish this video. God bless you all. Take care. Bye-bye now.